Hello everyone, I'm Yefan Chen from Huawei Global Training Center. Today I'm going to introduce open source distributed database cache products and talk about the selection. Before we talked about the open source distributed database cache products, let's look at the differences between commercial databases and open source databases and discuss the advantages and disadvantages of both. Commercial databases are stable and highly reliable, meet strict consistency requirements, and have powerful OLAP and OLTP capabilities. Commercial databases have more technical support and more cases that we can use as reference. However, the disadvantages of commercial databases include poor scalability, high cost, and poor concurrent processing and big data processing capabilities. On the other hand, open source databases feature high performance and high availability. With a distributed architecture, they support diversified data types and have good horizontal scalability. Additionally, they are free of charge and are not only SQL. The disadvantages of open source databases include fewer vendors can provide technical support and high operation and maintenance cost. Now let's compare key-value databases, traditional databases, and MongoDB. Key-value databases rank highest in terms of performance and scalability, while traditional databases are the worst. However, traditional databases rank highest in terms of functions, while key-value databases are considered to be far worse. MongoDB is a balanced option, ranking well in both aspects. For Internet service systems that require high performance and scalability, key-value databases are the best choice. Databases for Internet services have three major requirements. They must have a high concurrent read and write performance. They must be able to be efficient to restore and access large volumes of data. They must have high scalability and availability. Among open source software, Redis and MemCache are two most popular choices for distributed cache software. Now let's take a moment to discuss the characteristics and operating mechanisms of both Redis and MemCache. Redis is a high-performance and open-source BSD licensed key-value database written in the ANSI language. It is networked in memory and stores keys with optional durability. It offers APIs in multiple languages. It can be used as a database, cache, and message middleware. Redis supports multiple data structures such as strings, hashes, lists, sets, sorted sets with range queries, bitmap, hyperlogs, and geospatial index with Redis queries. Redis reacts fast. It can perform approximately 110,000 setting operations and 81,000 read operations per second. It typically holds the whole data set in memory and uses disks for persistence. Redis supports master-slave replication. Data from any Redis server can replicate to any number of slaves. A slave may be a master associated with another slave. How does Redis cache architecture differ from the traditional architecture? We can see from the figure that in traditional architecture, all user requests are read by the application server directly from the database, regardless of whether they have previously been read from the database or not. Well, Redis cache architecture enables user requests to be read by the application server from a Redis server. Only when the search is not discovered in the Redis server, then the application server reads data from the database. Now that we've covered Redis, let's discuss the functions of MemCache. MemCache is a free, open-source, BSD licensed, high-performance distributed memory object cache system. It maintains a unified huge hash table in memory, which is used to store various data, including images, videos, files, and database retrieval results. By storing and reading data from memory, MemCache greatly improves read speeds. MemCache is used by web applications to reduce database load. It caches data and objects in memory to reduce the number of times the database is read, thereby accelerating access to websites. MemCache and Redis have similar operating mechanisms. If a user or a client sends a request to a web application server, and the request is directly cached in MemCache, it is a hit and the steps 1, 2, 3, and 7 are performed. Otherwise, it is a miss. The steps 1, 2, 3, 4, 5, 7, and 6 are performed. That is to say, the data that is searched from a database will also be cached in MemCache. This figure shows a few examples of distributed MemCache algorithms, including the remainder algorithm and the hash algorithm. Now let's look at how MemCache uses these algorithms to read and write data. First, when an application server has a data write request, it sends this request to Redis. Second, the API sends the key to the routing algorithm module, which then calculates the server number, for example, node 1 based on the key and MemCache cluster server list. Third, MemCache obtains the IP address and port number based on the server number. Fourth, MemCache uses the API communication model interface to communicate with the server with a specified number and writes data to the server to complete a distributed cache write operation. The read cache algorithm is the same as the write cache algorithm. Now that we have covered the functions and characteristics of Redis and MemCache, let's look at a scenario where the two distributed technologies are used and discuss in which scenario is more appropriate to choose, Redis or MemCache. Looking at this table, we can see that Redis is more suitable for complicated cache scenarios, such as scenarios that have requirements for persistence, have high requirements for data structure processing, or have a variety of data types. For simple key value scenarios, MemCache is more suitable. Well, till now, we discussed the differences between commercial databases and open source databases, the functions and performance of different databases, and the three requirements for Internet service databases, open source distributed cache software, Redis, and its characteristics. Also introduced the difference between Redis cache architecture and the traditional cache architecture, compared MemCache and its operating mechanism, and when it is appropriate to select either Redis or MemCache. That's all for this part. Thanks for your attending.